So this lesson is broken up into two parts. We're talking about atomic structures, and we're going to learn how to count the number of protons, neutrons, and electrons from a chemical symbol in the periodic table. From there, we're going to draw the proper Bohr models in part 2. So here's examples of two chemical symbols that you would find on a periodic table. Now these particular two symbols have quite a bit of information associated with them. We have a name, we have a number below the name, we have a letter representing the element, or letters representing the element, and then we have a large number on the bottom of the symbol. That would be and we're going to talk about what each one of these in a minute. Some periodic tables have tiles that have a lot less information than this. They may only have the letter symbol and the atomic number. The name could be missing and the atomic mass could be missing. And I find those periodic tables quite useless as far as information, so I don't use them. In our class, we're going to give you a periodic table that has these 4 things on there at any one time: a name, the atomic number, the letter symbol for that particular element, or the symbols for that particular element, and the atomic mass. And I'm going to show you which one of these are which, and then we're going to use this information to help us understand what the structure of the atom is for that particular element. So our first thing is we're going to circle what the name is, right? So let's do that right now. And our name for this one is uranium, and our name for this one is calcium, right? So we're going to put over here real quick chemical name, name of element, name of element. All right, so the name of the element will always be on your periodic table, so you don't have to guess what it is, right? Because some of the symbols don't make sense compared to what the name is, and you'll see that for some examples like iron, something like that. Our next piece of information that we're going to always have in our periodic table chemical symbol is the atomic number, and that's this I'm circling right here. Unfortunately, I got the gray over the other one on the bottom, but it's the smaller of the two numbers on the tile, and the atomic number represents the number of protons. The periodic table is arranged in an increasing atomic number. Okay, that will always be on any periodic table, because without it, you don't know what the atomic number is. The third thing we're going to circle is the big letter or letters on the tile, and we're going to call that the letter symbol. All right, so each element has a different set of letter or letters associated with the name. So for example, here we have uranium. The symbol for uranium is always going to be U. The symbol for calcium is always Ca. Now notice that uranium has 1 letter and calcium has 2 letters. All elements will either have 1 letter associated with it or 2 letters. There is no 3-letter element. The other thing to be aware of is that when you look at an element, the first letter in its letter symbol is always capitalized. So calcium here, the C is capitalized, and the second letter is always lowercase, in this case the A. Uranium only has 1 letter associated with it, so it's always capitalized. Oxygen has a capital O, nitrogen a capital N, and so on and so forth, right? Titanium would have a capital T and a lowercase I. Okay, so this is either 1 or 2 letters, the first letter always being capitalized. And our last thing that we're going to look at real quick is this bottom number here, and that is our atomic mass, a weighted atomic mass. So we're just going to call it atomic mass for right now. All right, and it will show you how that's made up in a little bit later on. So this is the atomic mass. Okay, so those are the 4 things that we are going to be found on our periodic table. Now, one more thing to remember before we move on is sometimes these letters and names are going to be in different positions on the tile. Sometimes the letters, the name is going to be on the bottom of the tile. Sometimes the atomic mass is on the top of the tile, but all four of these will be in the tile at some place. The last thing to remember is you're always going to have an atomic number, an atomic mass on your tile. The atomic number is always the lower of the two numbers, right? The atomic number is the more important number for determining protons and neutrons and all that with the tile. So here is the chemical symbol for calcium, and this is a tile that you would find on a good periodic table. Now there's a couple of pieces of information on here that we have to understand better, and some we already know. So we already know that calcium, that's the name for calcium. So the element calcium has this two-letter symbol, Ca. And as I mentioned before, some elements only have one letter symbol and some have two. If it has one or two, the first letter is always capitalized. So if you only have one letter, it's capitalized. The second letter in a duo combination of letters for abbreviation for an element is always going to be capital letter, lowercase letter. One more thing about the letters. The letters don't always necessarily match with the beginning of the element name. For example, here calcium, Ca, right, matches the first two letters calcium. And that's the case generally most of the time. There are a few exceptions, one being iron, where the letter symbol for the chemical of the element of iron is capital F, lowercase e, and then for tin would be capital S, lowercase n. None of those letter combinations remotely mimic the actual name of the element. Alright, so the next thing we have to understand is what are these numbers? So let's look at the first number first. The first number is this 20. And this 20 is just the atomic number. And we said before that the atomic number is just a fancy way of saying it's the number of protons. Each atom of the element calcium will always have 20 protons. Each atom of the element calcium will always have 20 protons no matter where you look on the planet Earth, right? Every calcium atom always has 20 protons. If we take one of those protons away and have 19, we end up with a different element. If we add a proton, again, we end up with a different element. So the atomic number is like the fingerprint for that particular element. The second number we have to look at is this number down here. Now this number here is called the weighted average mass of all the isotopes naturally occurring for that particular element. Generally, this number is not going to be a whole number. However, we can use this information to help us understand what the mass number is for that particular element. And to get a rough approximation, we're always going to do a rounding. If this number here is 40.5 or more, like 0.5, 0.6, we can round up to 41 when we do our mass number calculations. If it's 0.49, whatever, and less, we're going to round down. Okay, so how does this relate to the mass number, which is right here? Okay, the mass number is just the number of protons plus the number of neutrons. And since you can't have a half a neutron or a half a proton, this number is always a whole number, whole integer number. However, again, remember, because this is a weighted average of a bunch of mass numbers, it's always going to be some type of decimal or fraction. But we can make some easy predictions by doing some rounding to get us to figure out this equation here. So in this particular equation, Z represents the number of protons, N represents the number of neutrons, and A represents the mass number. Remember, protons plus neutrons equals mass number. Now you may ask, well, why don't we include electrons? They're part of the atom too. And remember, the electron weighs so little compared to the protons or neutrons, about 1/2000th. For every 2,000 electrons, you get 1 proton as far as mass. That it's inconsequential. Inconsequential. So how do we figure out the number of neutrons if we know the number of protons and the mass number? Number of neutrons equals the mass number minus the protons. We just rearrange this equation right here. And the other nice thing about this, the number of electrons in a neutral atom, is going to be equal to the number of protons. The atom has to be electrically neutral, so for every positive charge, we need a negative charge. Electrons are negative, protons are positive, so they have to be equal and opposite each other. So if you have 20 protons, you need 20 electrons. All right, so now how we determine the number of protons, neutrons, electrons, mass number, atomic number, and the name of element symbol from the information that we have here. Now you might look at this and say, well, we really can't. There's not enough information to fill in these boxes. I look at this as like a Sudoku thing, right? And you do have all the information. So let's see which boxes are related, right? So we're gonna tie the ones that are related. So the first ones that we're going to tie together are the atomic number, the number of protons, and the number of electrons. In each one of these cases, the atomic number equals the number of protons, which equals the number of electrons. Remember, in a neutral atom, the atomic number is the number of protons. And since we have an electrically neutral atom, we can't have more positive charges than negatively charges. For every 1 proton, we need an opposite, a negative charge, so 1 electron. So these 3 boxes are all related. So whatever number you put in this box here is going to be the same for this box, which is going to be the same for this box. Okay? So we can go in right now and just fill them all in as we did that. Let's do that. So let's just go fill them in, right? So we know that the number of atomic number here is 12, so that means this is 12, and that means this is 12, okay? And we know that the number of 26 is here, and we said they're all equal, so 26 has to go here and has to go here. And we said that the number of protons here is 16, which means that there's 16 here for electrons, and the atomic number is 16. So we haven't done anything yet except just fill in a bunch of boxes with things that are equal. Okay, so let's look at the next relationship. We know that these two together, the mass plus the number of neutrons, the protons plus the number of neutrons, equals the mass number. So this part right here equals that box. So these 2 columns added up, here and here, has to equal the number in this box here. Okay, so let's see if we can fill in any boxes. Well, we have these 2 here right next to each other, so we can do these 2. And so we know that that is going to, 16 plus 15 is 31. So let's put 31 right here. Let's change the color. Let's put 31. So 31, 3, 1. That's a 3, not a 5. And then we do know that 12 plus 12 is 24. So we put that there. So we're really going pretty fast here, and we haven't really done anything. There's no real simple things to do except you just look at things that are the same in the electrically neutral atom and then go from there. Now, we also know that for right now we have this box here, and this particular box here, 56, we already know that number. And we know that 56 has to be equal to the number of protons plus the number of neutrons. So we don't know what the number of neutrons is. We certainly can get it. 56 minus 26 must equal the number of neutrons, and that would be 30. So far so good. Let's continue on because we still have a lot more things to fill in, but we're getting close now. So the last one here, this row here, seems to have the least amount of information in it. But we have a big piece of information right here, potassium. And we can look that element up on our periodic table, and we find that the element symbol to be K. And then we know that the atomic number of K is 19. And we know the atomic number must equal the number of protons, and it also must equal the number of electrons. So just by that piece of information right here, with our periodic table, this piece of information right here, with our periodic table, we were able to fill in most of the row. Now, the other thing we already know from that row is that we had 20 neutrons. These two columns right here again have to be added up to give me this column. And so when I do that math, I get 39. Okay? And the last column we don't have is we have a chemical symbol, but we don't have a chemical name. And we can look the chemical symbol up and realize that the name is just aluminum. All right? And now that gives us the atomic number of 13. 13 has to be equal to the number of protons, and that has to be the number of electrons. And now the number of neutrons plus the number of protons has to give me 27, so I have 13, plus some number gives me 27, and that number is 14. Okay, so we're not quite done. We've got a couple more empty boxes, but we have all the critical information we need to figure those out. Now we can just look on our periodic table and look up what atomic numbers match what particular element. So our atomic number for 26, we'll find that that's iron on our periodic table, so we write the word iron. And then we have the chemical symbol for iron, which is the two-letter code or the letter code, and that's Fe. The atomic number of 16 corresponds to the element sulfur. And that chemical symbol is S. And the last one is the atomic number of 12. The chemical symbol for that is magnesium, for Mg, and the name is magnesium. Magnesium. All right, so we filled that out in less than 7 minutes, and we didn't really have much information except what we had our periodic table, but we had common knowledge of which columns add up to which other columns. So again, these three columns are all equal as far as what values you put in. These two columns here added up give me the mass number. That's it. So now you're going to use this particular information and do the worksheet that I handed out to you in class, right? So you can use this as a guide, right, as a learning guide, but the information that you have on the worksheet should suffice you to get you the full activity done, right? And then we can review this in class. The second part of this lesson is to now use the information that we got from filling out that table to draw a Bohr model of that particular atom. So there's a couple of steps that we have to understand and how to do, and there's a couple of ways that we draw this. So we're going to go through those steps and right now, and then you're going to practice on a couple of ones in the video, and then do the worksheet that I gave you in class to finalize everything to make sure you fully understand it. Now, you've already done this in middle school and earlier on, so this should be just a review once you get the hang of it again. So the first thing is we're going to find our element on our periodic table. And then using the techniques I just described to you, determine the number of protons, neutrons, and electrons. Then you're going to draw a circle and label the correct number of protons and neutrons in the circle. For example, if you have 8 protons, you're going to write 8p, and 9 neutrons, you're going to write 9n. Then you're going to draw energy rings for the energy orbitals around the electrons in the Bohr atom, right? The first ring, second ring, third ring. You're going to keep adding rings energy levels until you run out of electrons to fill them. And let's see how that works on the next page. Now we're going to practice using the Bohr model by drawing a Bohr model. Now I've already pre-drawn some of the rings for you, but the bottom line is you're going to draw your own rings when we do this. So the first thing we're going to look up on our table is where does lithium fall, the periodic table. And you're going to find that lithium has an atomic number of 3. So let's write that down right now. We also know that if it has atomic number of 3, it has 3 protons. And we also know if it has 3 protons, it must have 3 electrons. What we don't know is the number of neutrons yet, but we can get that once we know the mass number. And where do we find the mass number? Well, that is the larger of the 2 numbers on the periodic table tile, the chemical symbol. So I believe for lithium it's 6.94. Well, that's not a whole number. So what we're going to do is we're going to round up to the nearest whole number or round down to the nearest whole number, depending on what the atomic weighted mass is. That will give me my mass number. So in this case, it's going to say 7. And we know from the mass number and the number of protons, we can calculate the number of neutrons, and that would be 4. So now how do we figure out the first one? So the first thing is we have to put in our center, we have to put 3p and then 4n. Okay? And we know we have 3 electrons. And there's a process for doing the electrons, and the electrons are filled up inner ring to outer ring sequentially. So we fill the inner ring first, and that always gets the first 2 electrons. So we just do that here. We'll put 1 electron here and 1 electron here. The first ring can only hold 2 electrons. So our next electron has to go into the next upper ring. And that goes here. All right, so we've got 3 electrons now. The first 2 are in the first energy level, and we have 1 in the second energy level. And we're done. So that was my Bohr model of lithium. So let's look at the next one. Oxygen. What is the atomic number of oxygen? You can look that up, and you can see it's 8. The mass number is 15.99994, so we're going to call that 16. Number of protons, 8. 8, the 2 equal, and the number of electrons is 8. And you can see here from the math that the number of neutrons is 8. So a lot of 8s here and a 16. So we wrote 8p, 8n. All right, 8p, 8n, and now we have to put in our electrons. Remember, the first 2 go in the first orbital, first energy level, sorry. And then the next, we can put up to 8 in the second level. So we do 1, 2, 3, 4, 5, 6. Now count them. Do we have 8 electrons? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Checks out. So let's go to the next slide. Okay, so our next one is magnesium. And if we find the atomic number of magnesium in our periodic table, it's 12. Let's write that the right color. So it's 12. The mass number, we don't know that yet. Number of protons is 12. Number of electrons is 12. And then we look up the mass of magnesium, and we can see that it's close to 24. So it's going to say it's 24, and therefore the number of neutrons is 12. So here's another simple one too. We have 12p, 12n. Okay? Good. Now we have to, how many electrons we got to put in? We have to put in 12. So where do the first 2 go always? In the first ring. And we can only put 2 in the first ring. We got 10 more to go. So we put 2, 1, 2, 3, 4, 5, 6, 7, 8. So we've added 8 more. We need 10. We ran out of room on our second energy level because we can only have 8 there. So the next thing we do is add another ring, and then we put 2. Right? We put 2. Okay? So let's count them up to make sure we have them all, right? We need 12 total, so let's start from the outside in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, so it checks. And the last one is argon. So we're going to look up argon. We find that's number 18. We don't know the mass number yet. We know it has 18 protons. We know it has 18 electrons. And argon has a atomic number of 36. Excuse me, a mass number of 36. So we put 36 here, and then we have number 18. So again, it's the same process. We're going to write the number of protons in here. So we'll put 18 P 18 N. Tells me the nucleus has 18 protons, 18 neutrons. Again, now we start filling up the electrons. Remember, the first 2 go in the middle, the smallest ring, and then we move up from there. So then we put 8 up here. We've got to put all 18 in. All right. So how many have I used up right now? I've used up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then my last ring gets another 8. All right. And we get another 8 here. All right. Try to make your electrons a little bit darker. Mind the pen here for the stylus is. But you get the gist, right? You've got 18 electrons surrounded on a nucleus that has 18 protons and 18 neutrons. And so that would be your Bohr model for argon. And I pretty much have given you great examples of how to do this. So now your activity is to do this on the worksheet that I gave you in class. And hopefully we'll come in tomorrow. And if you have any questions, let me know.